Hello there, and welcome to the Boring Universe channel. Tonight, let yourself settle into a comfortable place. Let your shoulders drop. Let your breathing slow down to its natural rhythm. There's nowhere you need to be, nothing you need to do, just you, here in this quiet moment. Tonight, we're going to travel together, gently, through the soft darkness of space to visit a distant neighbor. Not so far that we'll lose our way, but far enough to feel the wonder of it all. We're going to spend time with Proxima Centauri, the closest star to our Earth beyond our own sun. A small, patient light that has been glowing in the darkness for billions of years, waiting quietly in the cosmic night. Breathe with me now, in and out. Let the day fall away. Proxima Centauri sits about 4 light years from Earth. That sounds like a number, but think of it as a gentle distance. If you could walk through space, stepping 1 foot in front of the other, it would take you many millions of years to reach it. But that's all right. We have time. We have all the time we need. This little star has been there all along, and it will be there still, glowing softly in its corner of the universe. The star is red, not the red of fire or alarm, but the red of embers at the end of a long evening, the red of a sunset that lingers. Proxima Centauri is what astronomers call a red dwarf, a small star that burns slowly and steadily. It doesn't rush. It doesn't flare with urgency. It simply exists, pouring out its gentle light into the darkness. Imagine holding a dim lantern in your hand on a quiet night. That's what Proxima Centauri is like compared to our sun. It gives off only a fraction of the light, a whisper compared to a shout. If you stood on a planet near Proxima Centauri, its light would feel more like twilight than noon. A soft, perpetual dusk, the kind of light that makes you want to slow down and notice the details. This star is small, too, much smaller than our sun. If our sun were the size of a beach ball, Proxima Centauri would be about the size of a golf ball. Small, compact, glowing with quiet determination. Size doesn't measure worth in the universe. This little star has its own beauty, its own purpose. Proxima Centauri belongs to a family. It's part of a triple star system called Alpha Centauri. 2 larger stars, Alpha Centauri A and B, orbit each other in a slow, graceful dance. And far from them, at a great distance, Proxima circles around them both. It's like a child wandering in wide loops around 2 parents walking hand in hand. The little star keeps its distance, moving in its own gentle rhythm. For a long time, people weren't sure if Proxima was truly part of the Alpha Centauri family or just a passerby. But careful watching over many years showed that yes, this little red star is bound to its companions by gravity's invisible thread. It belongs. It's home. The star spins slowly on its axis. 1 rotation takes about 83 days. Imagine a world where a single day lasts nearly 3 months. Morning stretches on and on. Evening takes its time arriving. There's no rush in anything. Time moves at its own pace, unhurried and calm. Proxima Centauri is old, though not as old as some stars. It's been burning for about 4 to 5 billion years, roughly the same age as our sun. But because it's so small and burns its fuel so slowly, it will live much, much longer. While our sun will eventually grow old and fade in another 5 billion years, Proxima Centauri will keep glowing for trillions of years. Trillions. A timescale we can barely imagine. It's comforting somehow, knowing that this small light will persist long after we're gone. A steady presence in the universe. The light from Proxima Centauri takes just over 4 years to reach us. When you look toward it in the night sky, you're seeing it as it was 4 years ago. The light that touches your eyes tonight began its journey before you picked up this moment, before countless small events in your life unfolded. It traveled all that way, just to reach you now, in this breath. You can't see Proxima Centauri with your naked eye, though. It's too dim, too quiet. You need a telescope to find it. It hides in the constellation Centaurus, which is visible from the southern hemisphere. People in Australia, South Africa, and South America can see the constellation where Proxima lives. But even there, you'd need help to find the star itself. It's shy. It doesn't call attention to itself. The star gives off most of its light in infrared wavelengths. That's the kind of light we feel as heat rather than see as brightness. If you could visit Proxima Centauri, you might not see much, but you would feel its warmth on your skin. A gentle, constant warmth like sunlight filtered through clouds. Sometimes Proxima Centauri flares. The surface of the star erupts with bursts of energy, sending out waves of light and particles. But even these flares are part of its nature, not a sign of anger or chaos. Just the star stretching, releasing energy, being itself. The flares come and go, and then the star settles back into its quiet glow. Scientists have discovered that Proxima Centauri has planets, at least 2, maybe more. One of them, called Proxima Centauri b, orbits in what might be a habitable zone. That means it's not too close to the star and not too far away. It's in a place where water, if it exists there, could be liquid. We don't know if there's water on Proxima b. We don't know if there's life. But the possibility hangs there like a gentle question mark in the darkness. Proxima b circles its star every 11 days. Imagine seasons that last just days instead of months. Spring arriving, summer passing, autumn falling, winter settling, all in less than 2 weeks. Or perhaps there are no seasons at all. Perhaps it's locked in place. One side always facing the star, one side always in darkness. A world of permanent twilight on one edge, permanent night on the other. What would it be like to stand on a planet near Proxima Centauri? The sky might look different. The star would appear larger than our sun does to us, even though Proxima is smaller, because the planet orbits so close. The light would be red-tinted, casting everything in warm, dusky tones. Shadows would be soft. Everything would feel like it's bathed in the light of late afternoon. If you looked up from that world, you might see Alpha Centauri A and B as 2 bright stars close together in the sky. They would be the brightest points of light in that alien night, distant but beautiful. And somewhere impossibly far away, too faint to see, would be our sun, a tiny speck of light. Home, seen from across the cosmic ocean. The discovery of planets around Proxima Centauri is recent. For most of human history, we didn't know they were there. We looked at the stars and wondered, but we couldn't see. Now we know. Now we can imagine. And that's a gift in itself. Proxima Centauri reminds us that even the smallest lights matter. Even the dimmest star has worlds, has a story, has a place in the vast architecture of the universe. Nothing is too small to be important. Nothing is too quiet to be heard. The light from Proxima Centauri is patient. It doesn't demand to be seen. It simply exists, pouring its gentle red glow into the void, whether anyone is watching or not. For billions of years before humans appeared, before Earth even formed, Proxima was already there, already glowing. The star sits in a quiet neighborhood of space. Its companions, Alpha Centauri A and B, are about 13,000 times farther from Proxima than Earth is from our Sun. That's a vast distance, a silence between relatives. Yet they're still connected, still orbiting a common center of gravity, bound together by invisible threads. When you think of stars, you might imagine them as eternal and unchanging, but stars are alive in their way. They breathe, they pulse. Proxima Centauri has a heartbeat of sorts, a rhythm in how it releases energy. Sometimes it brightens slightly, sometimes it dims. A slow breathing in the darkness. The surface temperature of Proxima Centauri is about 3,000 degrees Celsius. That sounds hot, and it is. But compared to our Sun, which burns at about 5,500 degrees on its surface, Proxima is cooler. This is why it glows red instead of yellow or white. Cooler stars are red, hotter stars are blue or white. Each color is a temperature, a song in a different key. If you could somehow stand on the surface of Proxima Centauri, you'd feel that heat surrounding you, but you'd also sense something else. The star is smaller than our Sun, but denser. The gravity would pull at you more strongly. You'd feel heavy, anchored. But this is all imagination, of course. No one can stand on a star. Stars are made of gas and plasma, substances that flow and swirl. They have no solid ground. The magnetic field around Proxima Centauri is complex and strong. Magnetic fields are invisible forces that loop and spiral around stars, guiding charged particles and creating beautiful patterns. On our Sun, these magnetic fields create sunspots and solar flares. On Proxima, the magnetic fields are even more active, creating those flares we mentioned before. The star is wrapped in invisible energy, a protective cocoon of force. Sometimes these magnetic fields tangle and reconnect, releasing enormous amounts of energy in a flash. These are the stellar flares. During a flare, Proxima Centauri can briefly become much brighter, sending out bursts of X-rays and ultraviolet light. But then it settles down again, returning to its calm red glow. Like a person who occasionally raises their voice, but mostly speaks in whispers. The planets orbiting Proxima Centauri experience these flares. If there's an atmosphere on Proxima b, the flares might create auroras, shimmering curtains of light in the sky. Imagine standing on an alien world and watching green and red lights dance overhead as the star releases its energy. Beautiful and strange. We don't know yet if Proxima b has an atmosphere. To find out, scientists would need to study the planet more closely, watching how starlight filters through any gases that might surround it. This work is happening now, slowly, patiently. Answers come in their own time. The second planet, Proxima c, orbits farther out. It takes about 5 years to circle the star. This world is likely colder, farther from the warmth. It might be more like Neptune in our solar system, a giant ball of gas and ice. Or it might be something we've never seen before. Each planet is its own mystery. There might be other planets too, smaller ones we haven't detected yet. Moons might orbit the planets. Asteroids might drift between them. A whole family of worlds, all dancing around this small red sun. We're only beginning to learn what's there. When you look at the night sky, most of the stars you see are much farther away than Proxima Centauri. They're hundreds or thousands of light years distant. Proxima is our neighbor, relatively speaking. If space were an ocean, Proxima would be on the nearest shore. Still far, but not impossibly so. People sometimes imagine traveling to Proxima Centauri. With our current spacecraft, it would take tens of thousands of years to get there. That's too long for a human lifetime, too long for many generations. But maybe someday, with new technologies, the journey could be faster. Maybe someday humans or their creations will visit this distant shore and see what's there. For now, we visit in our imagination, and that's enough. Imagination is a kind of travel too. Close your eyes and you can be anywhere. You can stand on a red-lit world and look up at an unfamiliar sky. You can feel the gentle warmth of an ancient star on your face. Proxima Centauri has been photographed many times. In images, it appears as a small, reddish point of light, often surrounded by brighter stars. It's easy to miss if you don't know where to look. But once you find it, once you know what you're seeing, it becomes special. That tiny dot of light is a sun, a world maker, a cosmic hearth. The name Proxima means nearest in Latin. Proxima Centauri, the nearest of Centaurus, a simple descriptive name. But there's poetry in it too. Proxima, the close one, the one that's almost within reach, the one that reminds us we're not alone in the universe. Centaurus is the centaur in the sky, a mythological creature that's half human, half horse. The ancient Greeks saw patterns in the stars and named them after their stories. Centaurus was said to be wise and kind, a teacher and healer. It's fitting that our closest stellar neighbor lives in this constellation. A wise, patient presence in the night. From Proxima Centauri, if you look back toward our sun, you'd see it in the constellation Cassiopeia. Our sun would appear as a medium bright star, not particularly special, one among many. From that distance, you couldn't see Earth. You couldn't see any of the planets in our solar system. All our worlds, all our history, all our lives would be invisible, hidden in the glare of our star. This shift in perspective is humbling. We're so small, and yet we're here, aware, capable of wonder. We can look out at Proxima Centauri and know it's there. We can measure its distance, study its light, imagine its worlds. That's remarkable in itself. The universe is full of red dwarf stars like Proxima Centauri. In fact, they're the most common type of star. Our galaxy contains billions of them. Most stars are small and red and quiet, burning slowly for trillions of years. The big, bright stars like our sun are actually less common. We live around a relatively rare type of star, but each red dwarf has its own character. Proxima Centauri is special to us not because it's unusual, but because it's near. It's the one we can study most closely, the one we can almost touch with our telescopes and instruments, the one we might someday visit. The light from Proxima Centauri carries information. When scientists spread that light out into a spectrum, a rainbow of colors, they can see dark lines where certain elements absorb specific wavelengths. These lines are like fingerprints, telling us what the star is made of. Proxima contains hydrogen and helium, like all stars, but also traces of heavier elements: iron, magnesium, silicon, the building blocks of planets, the building blocks of life. These elements weren't created in Proxima Centauri. They were made in earlier generations of stars that lived and died before our sun and Proxima were born. When massive stars explode as supernovae, they scatter these heavier elements into space. New stars and planets form from this enriched material. We're all made of stardust, the saying goes. And it's true. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in the hearts of ancient stars. Proxima Centauri is made of the same cosmic recycling. It's part of the same story we're part of, connected across time and space by the elements themselves. The star doesn't make a sound, of course. Space is a vacuum, and sound needs air or water or some medium to travel through. But if we could somehow translate the activity of Proxima Centauri into sound, what would we hear? Perhaps a low hum, a deep note that vibrates slowly. Perhaps the occasional crack of a flare, like distant thunder. But mostly, a steady, quiet presence. A single note held for billions of years. Around Proxima Centauri, space is not completely empty. There's a thin wind of particles flowing out from the star, similar to the solar wind that streams from our sun. These particles are mostly protons and electrons, remnants of the star's outer atmosphere, pushed away by heat and radiation. The wind is gentle, invisible, but it fills the space around the star, creating a bubble called the heliosphere. Well, in Proxima's case, it would be called the astrosphere, a sphere of influence, a region where the star's presence is felt. Any planets in this system move through this stellar wind. It brushes against them, interacts with their magnetic fields if they have any, shapes their environments in subtle ways. On Earth, the solar wind is what creates auroras near the poles. Perhaps on Proxima b, something similar happens. Perhaps the sky lights up with colors we've never imagined. Time moves differently when you think about stars. A human lifetime is less than a blink to Proxima Centauri. Civilizations rise and fall, ages come and go, and the star barely changes. It's been burning for 4 billion years and will continue for trillions more. This kind of time scale is hard to grasp, but maybe that's okay. Maybe it's enough to know that some things are patient, enduring, constant. When you feel rushed or worried, when the world feels too fast, too loud, think of Proxima Centauri, burning quietly, glowing steadily, no hurry, no fear, just existence, pure and simple. The discovery of Proxima Centauri b in 2016 was a moment of wonder for many people. Here was a planet, roughly the same size as Earth, orbiting in the habitable zone of the nearest star. Could there be life there? Could there be oceans, clouds, maybe even forests, or creatures we can't imagine? No one knows. But the questions themselves are beautiful. Scientists used a technique called the radial velocity method to find Proxima b. They watched the star very carefully and noticed it wobbling slightly. The planet's gravity tugs on the star as it orbits, making the star move back and forth in tiny amounts. By measuring this wobble, astronomers could calculate the planet's mass and orbit. It's an elegant method, detecting the invisible by watching its effects. Proxima b is probably tidally locked to its star. That means one side always faces Proxima Centauri, and the other side always faces away. Like our moon, which always shows the same face to Earth. This creates a strange world. One hemisphere in eternal day, one in eternal night. And in between, a twilight zone where the sun never rises or sets, just hangs on the horizon forever. If there's an atmosphere on Proxima b, winds might blow from the day side to the night side, carrying heat and equalizing temperatures. The twilight zone might be the most comfortable place to be, not too hot, not too cold. A ring around the planet where conditions are just right. Imagine a civilization that lives in permanent sunset, where the sun never moves, where time is measured not by the passage of day and night, but by other rhythms. Or perhaps Proxima b has no atmosphere at all. Perhaps it's a barren rock scoured by stellar flares, baked on one side and frozen on the other. We don't know yet. The mystery remains. The second planet, Proxima c, is still being confirmed. Early observations suggest it's there, but more data is needed to be sure. Science moves carefully, checking and double-checking. It's better to be certain than to be fast. Proxima c, if it exists, would be a cold world, far from the star's warmth. Ice and rock, perhaps. A lonely place. But even lonely places have their beauty. A frozen world under a red sun, glittering with frost, silent and still. There's peace in such a landscape, even if it's not a place where life could thrive. The light of Proxima Centauri has traveled across the void for 4 years to reach us. 4 years. In that time, much has happened in your life. Seasons have changed. You've grown, learned, experienced. And all the while, this light was traveling, crossing the empty space between stars just to arrive here now, to tell us that the star is still there, still glowing. When you think about it, every star you see in the night sky is showing you the past. The light takes time to travel, so you're looking back in time with every glance. Some stars are so far away that their light has been traveling for thousands of years. You're seeing them as they were when ancient civilizations were building pyramids or writing the first alphabets. Proxima Centauri's light is recent by comparison, 4 years old, almost fresh, almost now. The astronomer who confirmed Proxima Centauri was part of the Alpha Centauri system was Robert Innes, working in South Africa in 1915. He noticed the star's motion and calculated that it must be moving with Alpha Centauri A and B. It was a quiet discovery, not celebrated with fanfare, but important nonetheless. One more piece of the cosmic puzzle falling into place. Since then, we've learned so much more. We've measured the star's properties, discovered its planets, imagined its future, but there's still so much we don't know. And that's part of the beauty. The universe doesn't reveal all its secrets at once. It makes us work, makes us wait, makes us wonder. Red dwarf stars like Proxima Centauri are stable. They don't go through dramatic changes like larger stars do. They won't swell up into red giants or explode as supernovae. They'll just keep burning, getting slowly dimmer over unimaginable stretches of time, until eventually, in the far, far future, they fade to black dwarfs, cold, dark remnants that no longer shine. But that's trillions of years away. For now, for all of human history and far beyond, Proxima Centauri will be there, glowing steadily. If humans ever do travel to Proxima Centauri, it will be one of the greatest journeys ever undertaken, crossing 4 light years of empty space, leaving the sun behind, arriving at a new star. The travelers would see things no human has ever seen. They'd walk on new worlds, breathe new air, if there's air to breathe, look up at a red sun in an alien sky. But even if we never travel there physically, we can travel in our minds. We can study the star from afar, send our instruments and telescopes to gather data, build our understanding piece by piece. We can appreciate Proxima Centauri for what it is: a neighbor, a fellow traveler in the galaxy, a small light in the darkness. The galaxy itself is vast. Our Milky Way contains hundreds of billions of stars. Proxima Centauri is just one. but it's our closest companion beyond the sun that makes it special, that makes it worth knowing. Think of the galaxy as a city of stars. Each star is a house with its own family of planets, its own story. Proxima Centauri is the house next door. We can see the light in its windows. We can wave from our porch to theirs. We can wonder what life is like there, what their days and nights are like, what their view of the universe is. In the grand scope of things, 4 light years is nothing. The galaxy is 100,000 light years across. The universe stretches for billions of light years in all directions. Proxima is practically on our doorstep, and yet even this tiny distance is immense by human standards. It puts things in perspective. We're small. Our planet is small. Our sun is one star among many. And yet, here we are, conscious and curious, reaching out with our minds across the void to touch the light of another star. The spectrum of Proxima Centauri's light also tells us about its motion. The star is moving through space, as all stars do. It's heading generally toward us, but at an angle. In about 27,000 years, it will reach its closest approach to our sun, about 3 light years away, and then it will begin to move farther away again. Stars drift, orbiting the galactic center, passing each other in the night. Neighbors come and go over cosmic timescales. But for now, and for many thousands of years to come, Proxima Centauri is our nearest stellar neighbor. We'll have time to get to know it better, time to send more telescopes, gather more data, maybe even send a probe. There's a project called Breakthrough Starshot that dreams of sending tiny spacecraft to Proxima Centauri. These would be small, lightweight probes propelled by powerful lasers from Earth. They'd accelerate to a fraction of the speed of light and make the journey in about 20 years. Once there, they'd take pictures, gather data, and send it back to Earth. It's an ambitious idea, still in the planning stages, but it shows that people are thinking about it, dreaming about it. Even if those probes succeed, the data they send back would take another 4 years to reach us. So we'd launch them, wait 20 years for them to arrive, and then wait 4 more years for the signal to come home. Nearly a quarter century from launch to results. That's patience on a grand scale. But maybe patience is what the universe teaches us. Nothing happens quickly in space. Stars take millions of years to form. Planets take millions more to settle into stable orbits. Life, if it arises, takes billions of years to evolve. The universe works on timescales that make human lifetimes seem like heartbeats. Proxima Centauri has seen our sun form, has seen Earth coalesce from dust, has been there for all of Earth's history. It was there when the first life appeared in our oceans. It was there when the dinosaurs walked. It was there when humans first looked up at the stars and wondered what they were. And it will be there long after we're gone, still glowing, still patient, still waiting in the darkness. There's a comfort in that continuity. The world changes, people come and go, but the stars remain. Proxima Centauri is a fixed point, a steady presence. You can look toward it tonight, and it's there. You can look tomorrow night, and it's still there. Year after year, generation after generation. The ancient peoples who lived thousands of years ago saw the same stars we see now. They told different stories about them, gave them different meanings. But the stars themselves haven't changed. Proxima Centauri was there then, though they didn't know its name or that it was the nearest star. It was just another faint point of light, lost among thousands of others. Now we know better. We know its distance, its mass, its temperature. We know it has planets. We know it's part of a triple star system. We've measured it, photographed it, studied it. But in some ways, the mystery remains. What's it really like to be there? What would you feel standing on one of its worlds? These are questions we can't fully answer yet, and maybe that's okay. Maybe some mysteries are meant to stay mysteries for a while. They keep us curious. They keep us looking up. The night sky is full of stories. Each star has been on its own journey, born from clouds of gas and dust, living out its life in the galaxy. Proxima Centauri is no different. It formed from a nebula, a vast cloud in space, collapsing under its own gravity until the core became hot and dense enough for fusion to begin. And then, light. The star was born. That was billions of years ago, but the process was the same then as it is now. Stars are still being born in nebulae throughout the galaxy. The universe is still creating, still bringing forth new lights. Around Proxima Centauri, there might be asteroids and comets, remnants of the planet formation process. These small bodies drift and tumble, occasionally colliding, sometimes falling into the star or crashing onto a planet. They're the leftovers, the pieces that didn't quite come together into worlds, but they're part of the system too, part of the family. On Earth, when comets and asteroids strike, they bring water and organic molecules. They help seed planets with the ingredients for life. Maybe the same thing happened on Proxima b. Maybe comets brought water to its surface, filling oceans, creating the conditions for life to begin. Or maybe not. Maybe Proxima b is dry and barren. We don't know yet. But the possibility is there. And possibilities are precious. They keep the future open. They remind us that there's more to discover, more to learn. If there is life on Proxima b, it would have evolved under very different conditions than life on Earth. The red light of the star would mean different chemistry for photosynthesis if plants exist there. They might be black or deep purple instead of green, absorbing every bit of light they can from the dim sun. Animals, if they exist, might have different senses. Maybe they'd see in the infrared, detecting heat instead of visible light. Maybe they'd navigate by magnetic fields or vibrations. Or maybe life there would be microscopic, simple, just beginning its long journey toward complexity. Singled cells dividing in a warm pool, unaware of the vast universe around them, unaware that 4 light years away, other beings are wondering if they exist. The idea of life elsewhere in the universe is both humbling and comforting. Humbling because it reminds us we're not the center of everything. Comforting because it suggests we're not alone. Somewhere out there, maybe, other eyes are looking up at other stars, asking the same questions we're asking. Proxima Centauri might be a bridge to that understanding, a stepping stone. If we can study its planets closely enough, if we can determine whether they have atmospheres, water, maybe even biosignatures, chemical signs of life, then we'll know more about how common life is in the universe. And even if we find no life there, that's valuable information too. It tells us about the conditions necessary for life, about how rare or common our situation might be. The search continues, telescopes are built, instruments are refined, data is gathered. Slowly, patiently, we're learning. On a clear night, if you're in the southern hemisphere, you can look toward the constellation Centaurus. You won't see Proxima Centauri with your eyes, but you'll know it's there, hidden in the darkness. A small red star, glowing quietly, surrounded by its planets, bathed in its own light. And maybe that's enough. Maybe just knowing it's there, being aware of its existence, is a kind of connection, a thread stretching across the light years, linking us to a distant shore. The universe is vast, but it's also intimate. Every photon of light that reaches your eye has traveled across space to find you. The light from Proxima Centauri, ancient and patient, crosses the void and touches you here, now. You're connected by that light. You're part of the same cosmos. When you breathe in, you're breathing atoms that were once part of stars. When you look up, you're seeing the past, the present, and the future all at once. The light that left Proxima Centauri 4 years ago is arriving now. The light leaving it now will arrive 4 years from now. Time and space weave together in the dance of the universe. Proxima Centauri is a reminder that the universe is not empty or cold or hostile. It's full of wonders, full of stars and planets and possibilities, full of light and darkness and the beautiful spaces in between. The star doesn't know we're here. It doesn't know we've named it, studied it, dreamed about it. It just exists, doing what stars do, burning, glowing, holding its planets in their orbits, pouring light into the void. But we know it's there, and that awareness changes things. It makes us curious. It makes us wonder. It makes us reach beyond ourselves, beyond our world, toward something larger. There's a peace in this reaching, a sense of belonging to something vast and ancient and ongoing. The story of Proxima Centauri is part of the story of the universe, and we're part of that story too. As you settle into rest tonight, let your mind drift toward Proxima Centauri. Imagine its red light, warm and steady. Imagine its planets, silent and mysterious. Imagine the vast distance between here and there, and how small and precious that distance is in the scope of the cosmos. Let yourself feel the connection, light traveling across space, time unfolding, stars burning in the darkness. You, here, aware of it all. Breathe in, breathe out. The universe is vast, but you're part of it. You belong here. You're made of stardust just like Proxima Centauri. You're both part of the same ancient dance. Close your eyes. Let the thoughts drift like stars across the night sky. Let the gentle red light of Proxima Centauri warm you, comfort you, remind you that even in the darkness, there is light. There is always light. Hello again, and welcome back to this gentle journey through the cosmos. Let's continue our quiet exploration of Proxima Centauri, that small red star that waits patiently in the darkness, 4 light years from home. There's no rush. We have all the time we need. Just breathe softly and let yourself drift with these thoughts. The name Proxima Centauri was given to this star because of its closeness to us. But there's another way to think about proximity. Every atom in your body was once inside a star. In that sense, you carry stars within you. You are close to the cosmos in a way that goes beyond distance. You are made of it. You are part of it. Proxima Centauri is approximately 4.24 light years away. If we wanted to be more precise, that's about 40 trillion kilometers. 40 trillion. The number is so large it becomes abstract, meaningless. But perhaps that's the point. Some distances are meant to be felt rather than calculated, vast, distant, and yet, in cosmic terms, remarkably near. The star's mass is about 1/8 the mass of our sun. Imagine our sun shrinking down, becoming smaller and denser, until it's just a fraction of its current size. That's Proxima Centauri. Small, but still a star, still a furnace of fusion, still creating light and heat from the simplest elements. Inside Proxima Centauri, hydrogen atoms are fusing together to create helium. This process releases energy, and that energy works its way slowly to the surface, where it radiates out into space as light and heat. The journey from the core to the surface can take thousands of years. Energy bouncing around, absorbed and re-emitted countless times, gradually making its way outward. By the time that energy reaches the surface and streams away as light, it has been transformed. It started as gamma rays in the core, high energy and invisible. But as it traveled through the star's layers, it was absorbed and re-emitted so many times that it shifted to lower energies. By the time it emerges, it's mostly infrared light, warm, gentle, red. This is the light that bathes the planets of Proxima Centauri. This is the light that, after traveling 4 more years, reaches our telescopes and tells us the star is still there, still burning. The temperature at the core of Proxima Centauri is about 15 million degrees Celsius, unimaginably hot. At those temperatures, matter doesn't behave the way it does here on Earth. Electrons are stripped from atoms, creating a plasma, a soup of charged particles. The atoms move so fast with so much energy that when they collide, they can overcome the electromagnetic force that normally keeps them apart, and they fuse together. This fusion is what powers the star. It's the same process that powers our sun and all the stars you see in the night sky. It's the heartbeat of the universe. Stars are the engines that create the elements, that pour light into the darkness, that make life possible. Without stars, there would be no planets. Without stars, there would be no elements heavier than hydrogen and helium. Without stars, there would be no light, no warmth, no life. We owe everything to these distant furnaces. Proxima Centauri, small as it is part of this grand process. It's doing its part, fusing hydrogen, creating helium, releasing energy. It will continue to do this for trillions of years, long after our sun has faded, long after Earth is gone. The luminosity of Proxima Centauri is only about 0.17% of the sun's luminosity, less than 1/5 of 1%. That's dim indeed. If you replaced our sun with Proxima Centauri, Earth would freeze. We'd be too far from the star to receive enough heat. The oceans would turn to ice. The atmosphere would condense and fall as snow. Life would end. But Earth isn't orbiting Proxima Centauri. Earth orbits the sun at just the right distance to be warm and welcoming. And Proxima b orbits Proxima Centauri at just the right distance for its star. Each planet finds its place in its own system. Each one belongs where it is. The habitable zone around Proxima Centauri is much closer to the star than Earth is to the sun. Proxima b orbits at about 7.5 million kilometers from its star. That sounds far, but Earth is 150 million kilometers from the sun. Proxima b is 20 times closer to its star than we are to ours. But because Proxima Centauri is so much dimmer, that closeness is necessary for warmth. Imagine standing on Proxima b. The star would loom large in the sky, much larger than our sun appears to us, but its light would be softer, redder. You wouldn't get a sunburn standing under Proxima Centauri's rays. The ultraviolet light that causes burns on Earth is minimal from this cool red star. The light would feel warm on your skin, but gentle. like standing near a campfire rather than under the noonday sun. The sky on Proxima b might be a different color than Earth's sky. Our sky is blue because of the way our atmosphere scatters sunlight. Blue light scatters more than red light, so the sky appears blue. But under a red star with different atmospheric chemistry, the sky might be orange or pink or even purple. We don't know. We can only imagine. If Proxima b has oceans, what color would they be? On Earth, water appears blue because it absorbs red light and reflects blue. But under a red sun, maybe the oceans would appear different. Maybe they'd be darker, absorbing most of the light. Or maybe they'd reflect that red light back, shimmering with crimson waves. These are the kinds of details we dream about, the specifics that make a world feel real, even though we've never been there, even though we may never go there. The imagination fills in what observation cannot yet reveal. The orbit of Proxima b is very close to its star, and it likely experiences strong tidal forces. These are the same forces that cause ocean tides on Earth, created by the moon's gravity. But on Proxima b, the tidal forces from the star are much stronger. Over time, these forces have probably locked the planet into synchronous rotation. One face always toward the star, one face always away. This creates a unique situation. The day side of the planet would be in perpetual light, the same landscape, always illuminated, never experiencing night. The night side would be in perpetual darkness. The same star is always overhead, never seeing the sun. Between these two extremes is the terminator, the line between day and night. On Earth, the terminator moves as the planet rotates, creating sunrise and sunset. But on a tidally locked world, the terminator stays in place. It's a permanent twilight zone circling the planet, a ring where the sun hangs forever on the horizon. This twilight zone might be the most habitable part of Proxima b. Not too hot, not too cold. A perpetual dawn or a perpetual dusk, depending on how you think about it. If there's life on Proxima b, maybe this is where it thrives. In the soft, constant glow of a sun that never rises or sets. The stellar flares from Proxima Centauri would be more intense on Proxima b than on Earth. The planet is so close to the star that when a flare erupts, it receives a strong dose of radiation. This could be harmful to life, stripping away atmospheric gases, bombarding the surface with particles. But it's also possible that Proxima b has a strong magnetic field that protects it, like Earth's magnetic field protects us from the solar wind. If the planet has a molten core, convecting and rotating, it could generate a magnetic field that deflects the worst of the stellar flares. A shield of invisible force, wrapping the planet in safety. We don't know yet if Proxima b has a magnetic field. It's one of the many unknowns. But the possibility exists. And where there's protection, there's the possibility of life. The second planet, Proxima c, is still being studied. It's farther from the star, orbiting at about 1.5 times the distance between Earth and the Sun. That's much farther than Proxima b. At that distance, even accounting for the star's dimness, Proxima c would be cold, very cold. Proxima c is thought to be several times more massive than Earth. It's likely a super-Earth or a mini-Neptune, a world dominated by rock and ice, or perhaps a thick atmosphere of hydrogen and helium, a gas giant that never grew large enough to become a Jupiter. What would it be like on Proxima c? Perhaps there are frozen plains stretching to the horizon, ice as hard as rock under a dim red sun. Perhaps there are mountains of water ice, glaciers that flow slowly over millions of years. Perhaps there are storms in the upper atmosphere, clouds of methane or ammonia swirling in patterns we've never seen. Or perhaps Proxima C has no solid surface at all. Perhaps if you tried to land there, you'd sink down through layers of gas, the pressure increasing, the temperature rising, until you reached a core of rock and metal far below. A journey into the depths of an alien world. There might be moons orbiting Proxima C. If the planet is large enough, it could have captured several moons during the formation of the system. These moons might be small and rocky, or they might be ice worlds themselves. Tiny spheres orbiting a larger world, all of them circling the distant red star. One of those moons, if it exists, might even have conditions suitable for life, heated by tidal forces from the planet it orbits, with a subsurface ocean kept liquid by the flexing of its interior, like Europa or Enceladus in our own solar system. Hidden oceans sealed beneath ice where life might flourish in the darkness. These are the possibilities that keep scientists searching. The universe is full of niches, full of unexpected places where life might arise. We're only beginning to understand the diversity of worlds that exist. Proxima Centauri itself is classified as an M-type star on the spectral classification system. This system organizes stars by temperature and color, from the hottest and bluest, O-type, to the coolest and reddest, M-type. M-type stars are the most common in the galaxy. They make up about 70% of all stars. Our Sun, a G-type star, is actually somewhat unusual. This means that if life is common in the universe, it's more likely to exist around red dwarf stars than around stars like our Sun. There are simply more of them, more opportunities, more chances for the right conditions to come together. Proxima Centauri represents the majority of stars in the galaxy. Understanding it helps us understand the cosmos as a whole. Each small red star is a laboratory, a place where we can study the processes that shape planets, atmospheres, and perhaps life. The brightness of Proxima Centauri varies slightly over time. It has a rotation period of about 83 days, and as different parts of the star's surface face us, we see slight changes in brightness. Some regions are hotter or more active than others. Star spots, similar to sunspots on our Sun, appear and fade, creating variations in the light we receive. These variations are small, but they're measurable. By studying them, scientists can learn about the star's rotation, its magnetic activity, its internal structure. Each flicker of light carries information if we know how to read it. The distance to Proxima Centauri has been measured very precisely using a method called parallax. As Earth orbits the Sun, our viewpoint changes slightly. Nearby stars appear to shift position against the background of more distant stars, just as a nearby tree seems to move against distant mountains when you walk past it. By measuring this tiny shift in Proxima Centauri's position over 6 months, half an Earth orbit, astronomers can calculate its distance using simple geometry. The smaller the shift, the farther the star. Proxima Centauri's shift is measurable but small, confirming its distance of 4.24 light-years. This technique, parallax, is one of the fundamental ways we measure distances in astronomy. It's been used for centuries, refined and improved over time. Now, with space telescopes, we can measure parallax with incredible precision, determining distances to thousands of stars. But even with all our technology, we can't yet visit Proxima Centauri. 4 light years is too far for our current spacecraft. The fastest human-made object, the Parker Solar Probe, travels at about 430,000 miles per hour when it's at its fastest. At that speed, it would still take about 6,000 years to reach Proxima Centauri. 6,000 years. That's longer than recorded human history. It's a timescale that makes interstellar travel seem impossible with our current technology. But technology changes. Things that seem impossible today might be routine tomorrow, or perhaps not tomorrow, but someday. In the meantime, we can send our light, our signals, across the void. Radio waves travel at the speed of light. A message sent to Proxima Centauri would take 4.24 years to get there. If someone received it and replied immediately, we'd get the response 8.48 years after we sent the original message. A conversation with delays measured in years. No one has detected any signals from Proxima Centauri. No signs of intelligent life. But the absence of evidence isn't evidence of absence. Maybe there's no one there to send signals. Or maybe they're there, but not using radio waves. Or maybe they're there and using radio waves, but we haven't been listening at the right time or the right frequency. The universe is vast, and the chances of 2 civilizations finding each other across the void are small. But small doesn't mean zero. The search continues. Telescopes listen. Data is analyzed. We keep looking, keep hoping, keep wondering. Proxima Centauri is part of the Alpha Centauri system, as we've mentioned. The 2 larger stars, Alpha Centauri A and Alpha Centauri B, are both more like our Sun. Alpha Centauri A is slightly larger and brighter than the Sun. Alpha Centauri B is slightly smaller and dimmer. They orbit each other every 80 years, a slow dance of gravitational partners. From Proxima Centauri, Alpha Centauri A and B would be visible as 2 bright stars close together in the sky. They'd be the brightest objects in Proxima's night sky, much brighter than any star we see from Earth. 2 suns, distant but brilliant, locked in their eternal waltz. And from Alpha Centauri A or B, Proxima Centauri would be barely visible, a faint red point of light far away, far. The 3 stars are a family, but they're not close. They orbit a common center of gravity, but the distances between them are vast. If there are planets around Alpha Centauri A and B, and there might be, then there could be multiple planetary systems, all within this one stellar family. Worlds orbiting A, worlds orbiting B, and worlds orbiting Proxima. A neighborhood of planets, all looking up at different configurations of stars. Imagine being a traveler in this system. You could visit a planet around Alpha Centauri A and see 2 suns in the sky. Alpha Centauri B as a bright star, and the sun of that planet itself. Then you could journey to a planet around Proxima Centauri and see Alpha Centauri A and B as 2 bright stars close together. Each world would have its own unique sky, its own perspective on the universe. The orbital period of Proxima Centauri around the common center of gravity of the Alpha Centauri system is roughly 500,000 years. 500,000. It's a time scale that makes human history seem like a brief moment. Proxima is on a long, slow journey around its companions, a journey that will take longer than humanity has existed to complete even once. But the universe is patient. Time doesn't hurry for anyone. Stars orbit on their own schedules, indifferent to the brief lives of civilizations. The stellar wind from Proxima Centauri, that stream of charged particles flowing away from the star, creates a boundary where it meets the interstellar medium, the thin gas that fills the space between stars. This boundary is called the heliopause, or in this case, the astropause, and it marks the edge of the star's influence. Beyond this boundary, the interstellar medium takes over. The particles there were not created by Proxima Centauri, but by other stars, by supernovae, by the processes that shape the galaxy. Proxima Centauri sits in a bubble of its own creation, surrounded by its planets, its stellar wind, its magnetic field. And beyond that bubble is the larger galaxy, vast and ancient. Our sun has the same kind of bubble, and humanity has sent 2 spacecraft beyond it. Voyager 1 and Voyager 2 have both crossed the heliopause and entered interstellar space. They're the farthest human-made objects from Earth, still transmitting signals back to us as they drift through the void. Voyager 1 is heading roughly in the direction of the constellation Ophiuchus. In about 40,000 years, it will pass within 1.6 light years of a star called Gliese 445. It won't reach Proxima Centauri, though. It's not heading that way. But imagine if it were. Imagine if Voyager 1 had been aimed at Proxima Centauri. It would take about 70,000 years to get there. 70,000 years of silent drifting through the void, passing by nothing, seeing nothing, just traveling. And when it arrived, what would it find? Planets, maybe, moons, asteroids, the dim red glow of the star. No one there to greet it, probably. Just a lonely spacecraft arriving at a distant shore, carrying messages from a civilization that might be long gone by then. There's something poignant about that image, something beautiful and sad. The human desire to reach out, to communicate, to connect, even across distances and times that dwarf our existence. Proxima Centauri doesn't know we're here. It doesn't know we've given it a name, measured its distance, discovered its planets. It doesn't know we dream about it, wonder about it, plan hypothetical journeys to it. But we know it's there, and that knowledge connects us. It makes the universe feel less empty. We're not alone in the void. There are other stars, other worlds, other possibilities. The light from Proxima Centauri is old by the time it reaches us, but not ancient. 4 years old. Recent enough that we can imagine the star as it is now, still glowing, still warming its planets, still pouring light into the darkness. When you look at the night sky and think of Proxima Centauri, remember that the light you would see, if you could see it, left the star 4 years ago. It's been traveling all that time, crossing the empty space between stars just to arrive here. In those 4 years, what has happened on Proxima b, if there's anything there to happen? Have storms crossed its surface? Have its continents shifted, if it has continents? Has life, if it exists, evolved in some small way, adapting to its environment? Or has nothing changed? Has the planet remained the same, silent and still, waiting in the red light of its star? We don't know, and there's a peace in not knowing. The universe keeps its secrets. It reveals them slowly, one discovery at a time, keeping us curious, keeping us engaged. The study of exoplanets, planets around other stars, is a young field. The first confirmed exoplanet around a sun-like star was discovered in 1995. Before that, we knew planets existed only in our own solar system. Now, we know of thousands of exoplanets, and there are probably billions in our galaxy alone. Proxima b and Proxima c are part of this growing catalog of worlds. Each one is unique. Each one adds to our understanding of how planets form, how they evolve, what conditions lead to habitability. Some exoplanets are gas giants, larger than Jupiter. Some are rocky worlds smaller than Earth. Some orbit close to their stars, scorched and barren. Some orbit far away, frozen and dark. And some, like Proxima b, orbit in the habitable zone, where liquid water could exist. Water is essential for life as we know it. It's a solvent, a medium in which chemistry can happen. Life on Earth began in water, and every living thing depends on it. So, when we search for life elsewhere, we look for water. But life might not need water. It might use some other liquid as a solvent. Methane, ammonia, something we haven't thought of. Life might be more creative, more diverse than we can imagine. The universe might be full of surprises. Still, we start with what we know. We search for Earth-like planets, planets with water, planets where life as we understand it could exist. And Proxima b is one of those candidates. The atmosphere of Proxima b, if it has one, is crucial. An atmosphere can trap heat, keeping a planet warm, even if it's far from its star. It can shield the surface from radiation. It can contain water vapor, oxygen, carbon dioxide, the gases that make life possible. Scientists are working on ways to study the atmospheres of exoplanets. When a planet passes in front of its star, a transit, some of the starlight filters through the planet's atmosphere. Different gases absorb different wavelengths of light, leaving fingerprints in the spectrum. By analyzing these fingerprints, we can determine what the atmosphere is made of. Proxima b doesn't transit from our viewpoint. Its orbit is tilted such that it doesn't pass directly between us and the star. So we can't use the transit method to study its atmosphere. We need other techniques, more subtle, more difficult. But scientists are working on it. Patience, always patience. The universe doesn't give up its secrets easily. The color of Proxima Centauri, that deep red, is caused by its surface temperature. At about 3,000 degrees Celsius, the star emits most of its light in the red and infrared parts of the spectrum. Our eyes perceive this as a red color. If you could somehow visit Proxima Centauri and look at it up close, it would appear red. Not the bright, cheerful red of a stoplight, but a deeper, richer red. The red of embers, the red of sunset, a warm, glowing red that would fill the sky. And that red light would fall on everything. Rocks would look red. Water, if there's water, would look red. Plants, if there are plants, would look red. The entire world would be bathed in this warm, crimson glow. It's hard to imagine because we're so used to the yellow-white light of our sun. Our eyes evolved under that light. We see colors the way we do because of it. Under a different star, colors would look different. Our perception of the world would change. But perhaps the beings on Proxima b, if they exist, have eyes adapted to red light. Perhaps they see their world as vividly and colorfully as we see ours. Perhaps to them, the red light is normal, and our yellow sun would seem strange and harsh. Perspective changes everything. What seems alien to us is home to someone else. What seems impossible to us might be everyday reality elsewhere. The mass of Proxima b is estimated to be at least 1.17 times the mass of Earth. At least because the detection method gives us a minimum mass. The planet could be heavier. It depends on the tilt of its orbit, which we can't measure directly yet. If Proxima b is about the same mass as Earth, it's probably a rocky planet. Rock and metal, with maybe a thin layer of water or ice on the surface. A solid world you could stand on. But if it's significantly more massive, it might be different. It might have a thick atmosphere of hydrogen and helium, making it more like a mini Neptune. Or it might be a water world with deep oceans covering the entire surface and no dry land at all. We don't know. We need more data, more observations, more time. In 2020, astronomers detected a possible signal in the radio spectrum that seemed to come from the direction of Proxima Centauri. It was a narrow band signal, the kind that might be produced by technology rather than natural processes. For a brief time, people wondered, could this be a message from another civilization? But after careful analysis, the signal was determined to be interference from human technology here on Earth. Not a message from Proxima Centauri, not a sign of alien life, just noise from our own devices, mistakenly thought to come from the stars. It was disappointing for some, but it's a reminder of how difficult the search for extraterrestrial intelligence is. Space is full of signals, most of them natural or created by us. Finding a genuine message from another civilization, if one exists, would be like finding a specific grain of sand on a beach. But we keep searching, we keep listening, because the discovery, if it ever happens, would be profound. It would change everything we think we know about our place in the universe. Proxima Centauri will outlive our sun by a vast margin. Our sun will burn for about 10 billion years in total, and it's already halfway through its life. In about 5 billion years, it will expand into a red giant, swallowing the inner planets, possibly even Earth. Then it will shed its outer layers and fade to a white dwarf, a small, dense remnant that will cool slowly over billions of years. But Proxima Centauri will keep burning. Red dwarfs live for trillions of years. Trillions. The universe itself is only about 14 billion years old. Proxima Centauri will outlive everything we know. It will see galaxies collide and merge. It will see the universe expand and cool. It will burn long after the last sun-like star has faded, and then, eventually, even Proxima Centauri will run out of fuel. It will stop fusing hydrogen into helium. It will cool and darken, becoming a black dwarf, a cold, dead cinder floating in space. But that's so far in the future that it's almost meaningless. It's beyond imagining. For now, and for all of human relevant time, Proxima Centauri will be there, glowing, waiting, constant. The Alpha Centauri system as a whole has fascinated people for generations. It appears as a single bright star to the naked eye, one of the brightest in the southern sky. Ancient peoples saw it and included it in their myths and stories. The Greeks saw it as part of the centaur, that wise and noble creature. Other cultures had different interpretations. To some indigenous Australians, the stars of Centaurus were part of stories about creation, about the journeys of ancestral beings. Each culture looked at the same stars and saw different meanings, different connections. Now we look at Alpha Centauri and see something else. Our nearest stellar neighbor, a destination, a place we might someday visit. The meaning has changed, but the wonder remains. If humans ever develop the technology to travel to other stars, Alpha Centauri will likely be the first destination. It's the closest, the most accessible. We could send probes first, gathering data, mapping the planets. Then perhaps crewed missions, if the technology allows. People stepping onto an alien world for the first time. What would they find? Would Proxima b be habitable? Would there be life? Would there be ruins of a civilization that came and went? Or would there be nothing but rocks and wind and silence? The questions are endless. The possibilities are vast. And until we go there, if we ever do, the questions will remain unanswered. But that's okay. Questions are valuable in themselves. They drive us forward. They make us curious. They remind us that there's more to discover, more to learn, more to wonder about. The night sky is an invitation. Every star is a question. Every planet is a mystery. And Proxima Centauri, our nearest neighbor, is the most immediate of these mysteries. Close enough to study, far enough to remain fascinating. Breathe in the wonder of it. Breathe out the need to know everything right now. Let the mystery be. Let the questions linger. There's beauty in not knowing. There's peace in the search. Proxima Centauri reminds us of our place in the universe. We're on one small planet, orbiting one medium-sized star, in one unremarkable part of a galaxy that contains hundreds of billions of stars. And beyond our galaxy are hundreds of billions of other galaxies. The scale is overwhelming if you think about it too much, but it's also comforting. We're part of something vast, something ancient, something beautiful. And in all that vastness, in all that scale, Proxima Centauri is our neighbor. The house next door in a city of stars that makes it special, that makes it worth knowing. The study of stars like Proxima Centauri helps us understand stellar evolution, the life cycle of stars. Stars are born from clouds of gas and dust. They live for millions or billions or trillions of years, fusing lighter elements into heavier ones. And then they die, either exploding as supernovae or fading quietly away. Each type of star has its own story. Massive stars burn bright and fast, living only a few million years before exploding. Medium stars like our sun live for billions of years, eventually swelling into red giants. Small stars like Proxima Centauri burn slowly and steadily, living for trillions of years, outlasting everything else. By studying Proxima Centauri, we learn about the most common type of star in the galaxy. We learn how these stars form planets. We learn how they age. We learn how their planets might support life. And all of this knowledge helps us understand our own situation better. Our sun, our Earth, our solar system, they're all part of the same cosmic processes. By looking outward, we learn about ourselves. The light from Proxima Centauri carries information not just about the star, but about the space it passes through on its way to us. As light travels through the interstellar medium, it can be absorbed or scattered by dust and gas. By studying how the light changes, we can learn about the material between the stars. This interstellar medium is not empty. It's filled with thin gas, mostly hydrogen, and tiny grains of dust. These materials were ejected by dying stars, scattered by supernovae, enriched with heavy elements. They drift through space, eventually collecting into new clouds that will form new stars and planets. Proxima Centauri's light has passed through this medium on its way to us. It carries the fingerprints of that journey. And by reading those fingerprints, we learn about the space between stars, the material that fills the galaxy, the cycles of creation and destruction that shape the cosmos. Everything is connected: the star, the space between stars, the planets, the life that might exist on those planets. All part of one vast interconnected system, one universe, one story, unfolding over billions of years. When you feel small or insignificant, remember this: you're made of atoms that were forged in stars. You're made of stardust. Every element in your body except hydrogen was created in the heart of a star or in the explosion of a supernova. You are literally made of the cosmos. And those atoms have been on a journey. They were once inside a star, fusing and changing. Then they were ejected into space, drifting for millions of years. Then they collected into a cloud that became our sun and our solar system. Then they became part of Earth. Then they became part of you. You are the universe experiencing itself. You are stardust that has become conscious, that can look up at the night sky and wonder about other stars, other worlds, other possibilities. Proxima Centauri is made of the same stuff, the same atoms, the same elements, arranged differently. It's your cosmic cousin, distant but related. The planets around Proxima Centauri, if they have life, are made of the same stuff too. Life anywhere in the universe would be built from the same periodic table, the same chemical elements: carbon, oxygen, nitrogen, hydrogen. The building blocks are universal, but the forms life takes might be very different. Evolution on an alien world would follow different paths, respond to different pressures, create different solutions. The life on Proxima b, if it exists, might be utterly unlike anything on Earth, or it might be surprisingly similar. Convergent evolution could lead to similar forms. Eyes, for instance, have evolved independently many times on Earth. Wings have evolved independently multiple times. Maybe some solutions are so effective that they arise wherever life takes hold. Maybe the beings on Proxima b, if they exist, look up at their red sky and wonder about other worlds. Maybe they've discovered that their star has neighbors. Maybe they're looking toward our sun, wondering if anyone is there. Maybe right now, as you read this, someone on a planet 4 light years away is thinking the same thoughts, wondering, dreaming, reaching out across the darkness with their mind. It's a beautiful thought. We might not be alone. We might have neighbors we haven't met yet. Or we might be alone. The galaxy might be full of planets, but empty of life. We might be the only ones, at least in this corner of space, at least in this moment of cosmic time. Either possibility is profound. Either possibility changes how we think about ourselves and our place in the universe. As we come to the end of our journey through the story of Proxima Centauri, let yourself settle even more deeply into this moment. Let your breathing slow. Let your thoughts drift like starlight through the darkness. We've traveled far tonight across 4 light years of space to visit a distant neighbor. We've imagined its worlds, its light, its place in the cosmos. We've wondered about what might be there, what might be waiting in that red glow. And now it's time to rest, to let go of the questions and simply be. Proxima Centauri will continue on its journey, orbiting the galactic center, burning its hydrogen, warming its planets. It doesn't need us to watch. It doesn't need us to understand. It simply exists, patient and eternal. And you can simply exist too. No need to understand everything. No need to solve every mystery. Just be here, now, in this quiet moment. The red light of Proxima Centauri, if you could see it, would be gentle on your eyes. Not harsh or bright, but soft and warm, like the light of a fire burning low, embers glowing in the darkness, comforting, peaceful. Let that imagined light warm you now. Even though you're not there, even though you're here on Earth, you can feel that warmth in your mind. You can picture that soft red glow, that patient star, that distant shore. The universe is vast, but it's also intimate. Every photon of light, every atom in your body, every thought in your mind, all connected to the great cosmic story. You're not separate from the universe. You're part of it. You belong here. And in this belonging, there's peace, there's comfort, there's safety. Close your eyes now, if you haven't already. Let the image of Proxima Centauri fade gently into the darkness. You don't need to hold on to it. It will be there tomorrow, still glowing, still waiting. Let your body relax completely. Let go of any tension in your shoulders, your neck, your face. Let gravity hold you. Let the earth support you. You're safe. You're here. You're home. The stars are far away, but they're also close. Their light touches you. Their atoms made you. You carry the universe within you, and the universe carries you. Breathe in slowly. Feel the air filling your lungs. That oxygen was made in a star long ago, scattered into space, gathered into our solar system, breathed by countless living things before you. You're breathing stardust. You're breathing the cosmos. Breathe out slowly. Let go of the day. Let go of worries, plans, thoughts. Just breathe. Just be. Proxima Centauri is 4 light years away, but in your mind you can visit it any time. You can stand on its worlds, feel its warmth, see its light. The universe is yours to explore, even from here, even in stillness. The night is quiet. The world is soft. The stars are watching over you, including Proxima Centauri, that small red light in the constellation Centaurus, our nearest neighbor, our cosmic companion. You don't need to go anywhere. You don't need to do anything. Just rest here, in this moment, held by the earth, warmed by the thought of distant stars connected to everything that is. The universe is ancient and patient. It has all the time in the world. And so do you. There's no rush, no hurry, just this breath and the next and the next. Proxima Centauri will burn for trillions of years. But you only need to think about this moment, this breath, this peace. Let yourself drift now. Let your thoughts become as soft and distant as starlight. Let sleep come if it wants to come, or simply rest in this quiet awareness, this gentle presence. You're safe. You're whole. You're exactly where you need to be. The stars are shining. Proxima Centauri is glowing, and you are here, breathing, resting, being. All is well. All has always been well. All will always be well. Rest now, dear traveler. The universe is holding you. The stars are watching over you, and the gentle red light of Proxima Centauri, our nearest neighbor, is glowing softly in the darkness, patient and constant, a small beacon of warmth in the cosmic night. Sleep well, dream of stars, and know that you are loved by the universe that made you. Good night.